Okay, so welcome here to lesson 2. We're just going to continue more of the index laws, some slightly more difficult examples. We're going to go through prime decomposition, and we're just going to continuously go through more simplifying using index laws. So let's make a start. Let's refresh our memory of all the index laws. Here it is, all nicely written down in a nice little table. And let's get started. So, the first question here, you can see again, we've got some combinations of index laws. We have division, which would be index law 2. We have some multiplication, which could potentially be index law 1, and we have powers of powers, which is index law 3. So first things first, let's just expand that 2, the power of 2 that we have, with the top part of the fraction. Okay, and so here we've got y is to the power of 6, not y to the power of 5. When we're having powers of powers with those brackets, we multiply. And now we can just use index law 2. And so x to the power of 4 divided by x to the power of 4 is just x to the 0, and 6 take away 5 is 1. Anything raised to the power of 0 is just the number 1, so we're just going to have y. Here, let's take care of the top part and the bottom part simultaneously. The only, same base terms that we have is the a's. So 5x plus 3x plus 6 gives us 8x plus 6. And at the bottom, the two b's are the same, so x plus 2. Now, with that in mind, we might subtract using. So with our a's here, we have 8x plus 6 take away all of 4. And so using brackets here would be a really good idea. Same thing with the b's. We have 2x plus 3 take away all of x plus 2. And so this here really makes it easy for us to not stuff up any of the positive or negative signs. Okay, so here 8x take away 4x, 6 take away negative 1, which will become a plus. Okay, so that should be 4x plus 7. And in the end, we should have here 2x take away x, 3 take away 2. So that's what we got written here. Notice how that negative minus and negative made a plus down here. And again, you don't really need to write this middle step here if you're confident, but eventually you will get 4x plus 7 and x plus 1. As soon as I see this, I know eventually I'm going to want to times and flip the second fraction. But let's just expand those powers outside of the brackets first. Let's get this 2 multiplied to everything. And let's get this negative 2 multiplied to everything. So we have all that written there. Hopefully that's all correct. Just double checking. Yep, divided by all of that. Now again, I have 2 fractions being divided. So I'm going to change this sign to a times, and I'm going to flip the second fraction. All I've done here. Okay, nothing else has changed. Now I'm going to deal with the top part. Okay, and so that's 9, because 3 to the power of 2 is 9. And then we've got a 4 plus negative 6. So it's 4 take away 6, and the b to the power of negative 2 stays the same. And then at the bottom, this became 4. Okay, this b6 and b negative 4 became a positive 2. And the 4 to the negative 2 stays as it was. So let's continue this in the top right. What we're going to do now is we're just going to simplify. we're just going to simplify these here. Okay, so here we've got 4 times 4 to the negative 2. Using index law 1, that's the same thing as 1 plus negative 2. Okay, and 1 plus negative 2 is just negative 1. Okay, so here we've got 4 to the negative 1 underneath. And now we can divide our common bases. So let's just deal with the, you can do that, or what they're going to do now is we're going to bring all the negative indices down to the bottom. So let's just show you what they've done first. So they've brought down the b to the negative 2 to the bottom, and the a to the negative 2 to the bottom. And so that will give us, and as well, the 4 to the negative 1 to the top. Okay, so whenever you change the sign, you just bring it to the top or to the bottom. Okay, so now we've got 9 times 4, and we've got a2, b2, b2. In which case we know that 9 times 4 is 36, and b squared times b squared is just b to the 4. And so we leave it at that. Let's now move on to something called prime decomposition. Okay, and this is just breaking down the number in as many factors as you possibly can until they're only prime numbers. So now we move on to prime decomposition, and all we're really going to do is break down each of these numbers into as many prime factors as we possibly can. So firstly, just pick any two numbers that you know multiply to give us 24. First thing I can think of is 6 times 4. Now let's see if we can break down each of those numbers. So 6 can be multiplied with 3 and 2, and 4 can be multiplied with 2 and 2. And so now let's just tidy this up. How many 2's do we have? Okay, 2 times 2 is the same thing as writing 2 squared, but we have 3 of them. So 2 times 2 times 2 gives us 2 to the power of 3. So this is what we call prime decomposition. 32 can be multiplied in a number of ways, but let's just go with 8 times 4. Okay, 8 can be broken down by 2 times 2 times 2. And 4 can be broken down with just a simple 2 times 2. And so we have 2 to the 5. 50. Simple one would be 10 times 5. 10 can be broken down with 5 times 2. And 5 just stays the same. We don't really want to go into timesing by 1, because that just does nothing. And so here we have 2 times 5 squared. And this is what we call prime decomposition. Okay, so simplify the following, expressing the answers in a positive index form. Firstly, if I was to break down the number 12, okay, I can have either 6 times 2, I can have either 12 times 1, but again we want to ignore the ones. But another one we would have is 3 times 4. Now the whole idea of this now is to have numbers that are similar for this 12 that they are to the 18. So if I break down 12 into 3 times 4 and 18 into 9 times 2, let's just pick any numbers that we know straight away, well then what we can do is break down these numbers further. 4 can be broken down into 2 by 2, and 9 can be broken down into 3 by 3. Then straight away we've done the prime decomposition. Okay, and what this is going to accomplish is it's going to really help us simplify this expression down to positive index form. So let's now multiply out these powers. Okay, and we're going to get 3n, 2n, 3, negative 4n, and 2, negative 2n. Now we can bring all these together, so this 3 and this 3 here can be simplified to 3 to the negative 3n, and this here can be simplified to 2 to the 0. And now anything raised to the power of 0 just becomes 1, and so we have, bringing that negative indice down, 1 over 3 to the power of 3n. Here, as you can see here, we've got all these numbers. Okay, and eventually we want to break this down in such a way that we can at least group them. So 3 can't really be broken down, but 6 can be broken down to 2 times 3. 12 can be broken down to 3 times 2 squared. Okay, if we want to skip some steps, it'd be nice. And 9 can be written as 3 squared. So I'm just going straight into the final prime decomposition answer. And then we can simplify. So let's just get those powers brought into those brackets. Okay, so as you can see here, this 4 will go here and here. This negative 3 will go here and here. And this will go here. So let's just take care of that. Okay, and now what we want to do is anything that's grouped up. So let's go for all the 3's. Negative 3 plus 4 is 1. Take away 3 is negative 2. And here we have 4. Take away 6 is negative 2. Now, we want to pretty much go straight away and do index law 2, which is dividing and taking away. So this would be negative 2 take away negative 8, which would be like plussing 8. And here would be negative 2 take away negative 2, which would be like plussing 2. So we should get 3 to the 6, 2 to the 0, which gives us 3 to the 6. Now if this said evaluate, then we would actually have to work out 3 to the power of 6. But it wants positive index form, so that's why we stopped there. Again, this can be broken down to 2 times 3, and this can be broken down to 2 to the power of 3. But clearly in this step here, they've decided to just take it a little bit longer. I would have gone straight to the 2 to the 3, but this still works. Okay, this n will be multiplied to each number, and this n will be multiplied to each number. It still works out the same. This just probably could have been done in one quicker step. So 3 to the 2n, 2 to the n, 3 to the n, 2 to the n, 2 to the 2n, and 3 to the n. There's probably a reason for that, okay? But again, if you chose to go 2 to the power of 3 straight away, then it will probably still work out. Just a matter of which way is quicker. So here, 3 to the 2n times 2n, as we've added these here, and all the 2's would become 3n. Alright, now what we're going to do is we're going to divide. So 3 to the 3n, take away n, gives us 3 to the 2n, and n take away 3n gives us negative 2n. We don't want negative powers, so we bring that down. And so now this will simplify down to 3 over 2 to the power of 2n. Now there is another way that we could do this. Again, your choice. It's just exposing you to all the index laws. So if this was the question here, refresh your memory. Let's do the prime decomposition. Same thing again. Let's do this exact same step again. So far the first two are exactly the same. Now what we could do is this 3 here could be broken down into So 3 to the 2n could be broken down into 3n times 3n. Okay? Because we're going backwards with index law 1. Now this is, again, completely optional. And this here, this 2n, 2 to the 2n, could be written down as, hopefully you've guessed it by now, 2n times 2n. So that's what I've done here. And so now it becomes super easy to just cross out anything that's on the same top and bottom. So 3n and 3n, 2n and 2n. So we're left with exactly what we got here. 3n, 2n. Oh, actually not really, sorry. Take that back. Not exactly the same. But it will eventually get us down to here, which is what we got there. Anyway, there is multiple different skills that you can do here. It's just going with what makes most sense to you. As long as you're not making any errors, not using the wrong technique, you can essentially do whichever one you want. Simplify the following. Okay. So, rewrite the given, this is exactly similar to what we were doing before, just a bit more of a challenging example. Rewrite the given bases in terms of their prime numbers, their prime factors. So instead of having 9, we have 3 squared. Instead of having 27, we have 3 to the power of 3. And the one at the bottom stays the same. Now the whole idea here is to get everything to the power of base 3. So if we expand out those brackets, you'll get 10m. And don't forget, now this here is like, it gets a bit intense here. So that times that. So this is like 3 2m minus 1, which is 6m minus 3. And at the bottom is the same. So now what we're going to do is we're going to simplify the numerator by adding the powers. 10m plus 6m minus 3 and keep the bottom the same. Simplify 16m minus 3 and 3m plus 1. And now we can just do the subtractions. Keeping in mind it is 16m minus 3m, negative 3m minus 1. So if we had like double negatives, you would need to do the plus. But in this case, we don't. Last example. Okay, so we've got the 4, we've got the 8, we've got the 2, we've got the 16. Now, if you know your powers well, you know that 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and 2 to the power of 4 is 16. So you know straight away that everything works to the base 2. And then we expand out our brackets. Again, don't forget this one here, 3x plus 3 equals 3x plus 9. And so from here, now we're going to simplify the top and the bottom. So we've got 7x plus 9 and 3x minus 4. Then we subtract, looking out for some negatives. So let me just put a little step in between. 2, 7x plus 9 in brackets minus 3x minus 4. So that's 7x minus 3x and that 9 minus negative 4. That's where that plus comes from. Simplifying that, we get 2 to the power of 4x plus 13. And that's lesson 2. Don't forget to look at the questions that you need to do, which is all from exercise 13A, question 8, 10 CD, 11 and 12.